Hi everyone, hope you guys are doing good. In this video, I'll be covering the 19th question from Chapter 7, Exercise 7.1, CBSE Part 2 Math Syllabus. Alright, let's get started. So in the 19th question, we have to find out the integral of secant square x, the whole divided by cosecant square x. Now looking at the question directly, we know that we do not have any formulas that could solve the question directly. So the next thing that we have to do right now is to try to simplify them. Now in case of simplification, it would be very easy for me to convert this in terms of sine and cos, and thereafter I could proceed on. So the next thing that I'm going to do right now is to convert secant into cos and then cosecant into sine. Alright, so secant square x I can write it as 1 by cos square x, and then cosecant square x I can write it as 1 by sine square x, the whole into dx. Now I do know that these are two fractions, and if I reciprocate them, for example, if we have two fractions a by b, the whole divided by c by d, if I reciprocate the denominator, this now becomes a into d, the whole divided by b into c. Now this is exactly what I'm going to do out here as well. So reciprocating the denominator in the integral function, this now becomes sine square x, the whole divided by cos square x into dx. Now this is nothing but integral of tan square x dx. Now this looks much simpler, but then yet again I do not have any formulas that could solve this directly. So what can I do? Why not use trigonometric identities? Yes, as I told you guys in the previous video, if you have trigonometric based functions inside integrals, then it's very much possible that for you guys to apply trigonometric identities as well inside it. So if I could convert this in terms of sine, I do have a function that could directly solve this. So I'm going to use a trigonometric identity here that could solve this up. So we know that there's a trigonometric identity that is secant square x is nothing but tan square x plus 1. Now if I could write this in terms of secant, this now becomes tan square x is nothing but secant square x minus 1. Now this is exactly what we need. I'm going to substitute this out here. So this now becomes secant square x minus 1 the whole into dx. Now I'm going to split these two integrals by using the first formula here. This now becomes integral of secant square x dx minus integral of 1 dx. Now we do know that integral of secant square x is nothing but tan x. So we have tan x plus c1, and then integral of 1 is nothing but x plus a constant term c2. Now wait, I should be ideally writing this as minus c2, but that having a constant as a positive or a negative term does not make any significance. So I'm just going to leave the constant term as a plus c2 itself. Now, as usual, if you add two constant terms, c1 plus c2, it's still going to be a constant. So I'm not going to have two separate terms to denote it, rather have it as one single term as plus c. So after replacing that 2, we have tan x minus x plus c. Alright guys, that's it. See you guys in the next video. Bye bye.